Hello, big data and BigQuery developers. My name is Michael Manoochehri from the Google Cloud Platform team. We have a special show for you today, a real treat. Joining me today for the first time on Google Developers Live is Felipe Hoffa, our newest team member. Felipe Hoffa is joining us on the Google Cloud Platform Developer Relations team. Yesterday, the BigQuery team launched a set of new features for BigQuery, and Felipe wrote a really great blog post about this on the Google Cloud Platform and Google Developers blogs. And so today we're going to take a look at some of these new features. We're going to talk about some use cases that they're really good for, and do some demonstrations about what you can do with these features as well. So Felipe, do you want to talk about one of the ones that's one of my favorite? My favorite ones.
Hello, everybody. Welcome to our. This is my first ever DDL video, so I hope you enjoy it. And yes, we are bringing today these new features. Let's talk about the first one.
Yes. So this is actually my favorite one, and I haven't tried out a lot of these, so I'm going to be learning about some of these for the first time from you. And since you went through all of these in your blog post for our blog, you're probably the person who can explain these the best.
Oh yes. You've been talking to developers for a long time. You know what they're doing. You know how they are enjoying BigQuery. But they frequently have one big request.
Yes.
Yes. What's this request?
Literally a big request. Something that we've been asked for since the beginning of the BigQuery launch was to have a result set size that's large as can be. Currently, well, until yesterday, the maximum result set you could get from a query was 128 megabytes of data compressed, which is a lot. I mean, that's quite a lot of data.
Exactly. So people were hitting this limit. It's a weird limit to hit because BigQuery strength is going from big data sizes, as Michael says. It goes from
machine-sized data to human data.
Exactly. So you have a terabyte database, you have a 10 terabytes database, and you need to get knowledge from it. You want to aggregate this data into understandable windows. And basically, you could always do that with BigQuery. But sometimes people needed to get a big table from a big table. For example, to transform a terabyte long table into another thing, add a column, transform the data. And they were hitting this limit of 128 megabytes of compressed data.
And this actually happens a lot when you're working with terabyte-sized data sets. Sometimes your result set, it can be a gigabyte, and that's quite a lot of data. It's hard to use that in, say, a dashboard situation. But sometimes you need to get that result size back. And that's normal when your actual set of data you're querying is in the terabyte range. You'll see that you sometimes need just a slice of that, and that could be a couple gigabytes.
Exactly. So what did we release yesterday? We are raising that limit. There is no limit now. You can have a result set of any size with the new flag, allow large results. What does this do? You give it a name for a table, and it will it will leave all the data in a new table, or it will append to an existing one.
Okay, so this is a question I have. Does that mean it doesn't return the result set as a JSON object, as a normal query does? It actually will just create a table that you can then request data from using the table data list function? Is that how that works?
Exactly, yeah. But basically, if you are getting a result so large, it's not really convenient to have it in a JSON for being returned on the network. So it makes sense to put it on a new table and to query from it. It's also pretty convenient if you have a terabyte table, that BigQuery is charged by how much data it processes in each query. So you may want to separate this terabyte table into several gigabyte size tables.
All right, so this is super useful if you've got something like a year's worth of data and you want to cut your data set up into like weeks or months or something like that, where you do need a huge result set, but you're going to use it later for other queries. So that's really useful. This also, I can't wait to try this feature because it solves a problem that I've always had, which is timestamps in different formats. So last time we did a BigQuery launch, we released a native timestamp format, which everybody had been asking for. And until then, we had to put timestamps as strings or integer Unix epoch values, and that can be pretty annoying when you want to use the native timestamp. So now what we can do is we take our terabytes of data, we can run a query that says cast this to a different timestamp, and then just export that as this new table, which is great. I think this is going to be super useful. So developers, I think, are going to love this a lot, and we'd love to hear how you like it. If you have any problems using this flag, I wanted to say one thing is this: like, why do we have this option? Why do you have to choose the option of like, a flag? And I think it's because when you're making these tables, they can be really big, and we want to make sure that you're generating these large tables because storage does cost you something in BigQuery. So we want to make sure you're doing it. That's why we have this flag.
And when you're using this flag, you are losing one feature. You can't order by the entire result set. Basically, sorting a terabyte data table for only one result is a big task. So that's disabled. But you can do that on your smaller result sets.
Okay, so you can actually run a query, make this big table. You can't order it in that table, but then you can run a query later to do an order by or something. Okay, so that sounds pretty good. I think a lot of our developers are really going to like that. It's been one of our most requested features. And so the BigQuery team is like, they take a lot of pride into listening to what developers want and actually releasing the features that are most requested. So I think that another one that's most requested, well, that's been requested for quite a while, is one that you talked about yesterday, which I need to learn more about.
Yes, I think you are talking about the window functions.
Yes, the window functions.
Yes.
What are window functions?
Well, window functions are giving you the ability to analyze your data in smarter ways. You are dealing with a lot of data, you are sorting it, you are ordering it, but sometimes you want to get a row number. BigQuery wasn't giving you a row number for each result. That was pretty easy to run before because you get your results, you can get a row number on the application side, but sometimes you want to use that number for further queries.
Right. So the window function, the way I understand it is you can run a result, you can run a query and get a result. And then once you get that result, this batch of data, a window function is something that you run on top of that.
Exactly.
So you get this result and then you do something else with that result. One of them is adding row numbers. So this is something you do after the result has been run.
Exactly.
So row numbers, that's cool. A lot of people have been asking us for that. So what are some other examples of things you do after the query?
Well, row number has many variations. You can turn it into a rank where you are ordering your data. The rank, there are many ways to, or there are at least 2 ways to solve equal values. When there are ties, you can say they are in a different rank just because one comes after the other by chance.
So this is a lot of our developers are game developers. They love to put game analytics, and so this is awesome because you can actually take this whole set of data and you can find out things like, well, first of all, row numbers are useful, like what's the first place. But if you want to do a ranking, you could say of all the things in my database, what are the first, second, and you said if there's a tie in the ranking, what happens?
Yeah, you can solve it in many ways. Yeah, you can rank your players 1, 2, 3, 4 in an arbitrary order if there is they have the equal score. Or you can rank you can give the same rank for people that have the same score.
Right. Okay, this is awesome. Do you think we could show like a quick demo of how these functions work?
Yes. I guess you have seen what we did for I/O. We put out 500 sensors all around Moscone. And we got a lot of readings: temperature, humidity, noise.
If you're interested in this project, by the way, we called it the Data Sensing Lab. We worked with the O'Reilly Data Sensing Lab team, and our teammate Kim Cameron up in Seattle did a great Google I/O video, which is available on YouTube. You can go check it out. It's called Behind the Data Sensing Lab, and Amy Unruh from the App Engine team was also involved with that. So the data we collected from that, we have it in BigQuery right now. We're going to actually release it for everybody to use as soon as we can. But the example you're going to do is based on this data?
Yes. Let's take this data. You will have it available to run your own experiments. But let me run some experiments now with it. Can we switch to the computer? I have here my table from Moscone I/O 13.
So this is the schema of the data, right? So you've got like a timestamp. Actually, we have multiple timestamps. I remember that we had different places where the data was being sent, and at every location we'd have a different timestamp. So the sensor had its own. The App Engine app we were collecting the data in has its own timestamp because it took a little bit of time. So we have multiple timestamps.
Exactly.
What else is in here?
The data is a very important one. That's
the
where
data
we get
itself.
The data. And we got the sensor type. So are we measure Does this row have a temperature? Does it have a noise reading, an air quality reading?
So each sensor had different types. Each like sensor that we placed around Manoochehri was measuring different things, like the temperature and the pressure and things like this. These are the kind of functions that you see a lot in relational databases, often when the data can be small. But what's great about BigQuery is now you can run these kind of queries over really large data sets, like easily via API. These like terabyte data sets. I think it's fantastic.
Yep. We will talk about this. This query ran very fast because it's cat. I'll tell you more about that.
I heard about
later.
this.
Yes. So we have the median. And you can see that we got 3 million data points.
So quite a lot.
Quite a lot. Yeah, and each one, let's go to the last. For example, in the wallet room, the median was 29.
Okay.
But we have many values for this median because it's going through the window.
Every data point, right? Basically.
Every data point is getting the median for that room. So we really want to group this data.
Right.
And we can do that very easily with this query. Let me run it and I will tell you more about this. So we are running the same query. And now I'm grouping the data. Max median is the same as minimum median because it's all the median is the same for each room. And I'm grouping by room.
Okay, so this is cool. So you're showing me the median temperature over all the data that we collected, which is a lot of data, and by room. So like in this case, we're calling the hallway a room and the lounge is a room. This is great.
So we have 72 rooms in Moscone and each one has its median temperature.
I saw the word blimp there. I remember we put some of the sensors in the blimps that were floating around, which was very fun.
Oh yes, this was very cool. We had three sensors there. So now, as last time, and now I'm doing a dense rank over it. I'm ordering it by median in an ascending order. So first I get the coldest rooms in I/O.
Yep. Looks like the coldest room was the entrance, which makes a lot of sense.
Oh yes.
Okay. Great. So this is wonderful. So for the sake of time, we have a lot of other things to cover, but what are some of the other window functions that are available? There was one called with ratio. Can you explain that ratio?
Ratio to report, that one is great. With that, we could see how much of a contribution each data point makes. I was running some queries yesterday that I wanted to know the ratio of men to women. So I was able to count them, as you have always been able to count.
Right.
And then with that count, I was asking the ratio to report. What does this number represent as a percentage of the total?
Okay, so this is, I remember you explained this to me yesterday. So the one thing I thought was a great use case is if you're doing sales or something related to that. You could say, or even if you have more data, log files. So you could, what ratio to report does, correct me if I'm wrong, is sum up everything in a column. And then whatever field you have that you're comparing it to, it's that contribution to the sum. So you could do things like, what contribution does this particular salesperson have to the total amount of sales? Or what contribution does this player have to the total amount of games being played? Things like that, which is really amazing, especially if you have these really large data sets.
Oh, yes.
You can get these things in a single query without having to do extra joins, things like that.
Exactly. Previously, you could do that with an extra join. There were smart ways to solve it,
right.
But now it's smarter.
Incredibly fast. How did you do that?
I'm using a cache. I already computed once.
Yes.
And that's what BigQuery can do now. It can remember.
So you remembered the original query result, and you just told me immediately without having to run the whole thing over.
Exactly.
And so BigQuery does this now too?
Yep, BigQuery is getting smarter and faster.
Yes.
If you ask the same question and it has the same answer,
right.
BigQuery will save that answer.
So it caches the answer. This is very smart. It caches the answer. So now instead of waiting 7 seconds for your query, you get it immediately. So caching is hard. Like, let me ask you a few questions about caching because I'm trying to understand how this works. Caching works when the table might not change. But what if I add data to the table? Then what happens to the cache?
Well, in that case, the cache goes away.
The cache goes away.
Yeah, BigQuery is smart about this. It realizes the table is not the same, so it will just dump the previous results and let you get new results.
Right. And in your blog post, you talked about deterministic queries. So the one example of this is if I have a query that depends on a current timestamp. I'm not actually putting the timestamp, but I'm asking BigQuery to tell me. Then every time I make that query, the timestamp changes. So does that get cached too?
No, that doesn't get cached. If you want your data to be cached, you have to use deterministic queries. What is a deterministic query? A query that where its meaning doesn't change with time. For example, if I use now function, now changes every time I query. So current time won't be the same. The query doesn't get to be cached.
Okay, so that's great. So any query that if the table doesn't change and your query itself literally doesn't change and does not depend on some of these functions like now, then it will be cached.
The limit of queries per day.
Okay, so the query quota limit doesn't change, but the queries do return faster.
Yes.
So okay.
And you don't get charged for them.
And you don't get charged for them. Okay,
Yes.
That's excellent. I think people are going to like that a lot. Okay, so so we have a bunch of other things. Let's just zip through the rest. I'll just say one more thing. This particular function and the large query results are now available in the API, and you can read about that on our documentation and the BigQuery command line tool. And I believe all of these are also available in the UI itself. So you can actually say, large results in the UI or cache the query in the UI, things like that.
Exactly. We have 3 ways to access BigQuery now. We have the BQ tool, we have the web UI, and we have the API.
Right.
They both allow this option.
Okay.
Also, you might want not to have a cache for some queries, just to run interactive demos. In that case, you can go in the web UI to enable options. You are able to set them on or off as you want.
Okay, excellent. Okay, so so speaking of dashboards, let's just touch on some of the other things we launched. One was an increase in the quota for querying, right? So before yesterday, the maximum amount of querying you could do is 200 gigabytes at a time. So if all your querying processing had to add up to 200 gigabytes, plus we gave you one extra query of any size. That's so you could do these massive queries. So now we've actually increased that. And can you remind me what the increase was? It was
Yes, we are doubling the quota.
We're doubling it. Okay.
We are doubling the 200 gigabytes, and we are doubling the unlimited queries from 1 to 2 at a time.
Right. So that Felipe and I are always talking about accessibility, and I think the whole point of BigQuery is to make these large data processing tasks more accessible via API for developers. And this pricing changes, the query caching, and the quota updates are just meant to increase the accessibility. So we're really excited, and I think it's going to help developers a lot with their needs.
And about pricing, are you a high volume user?
Oh, I definitely am.
Yes.
I use BigQuery like tons all day long.
Exactly. If you are a high volume user, there are also good news for you because you are able to opt in for tiered pricing, where you have further discounts. So more good news to use more of BigQuery.
Great. So yeah, we can't wait. I guess the other thing we've done is I mentioned it before. We've added some UI updates. We've updated our client libraries. We've updated our BigQ command line tool, and so just we've also updated our documentation. So please just go check out our documentation at developers.google.com/BigQuery. And yeah, and if you have questions, there's a lot of places you can reach us. You should definitely follow the Google Cloud Platform G+ page. There's also the Google Developers Plus page. Again, reach out to us on Stack Overflow at Google-BigQuery. And you can follow Felipe and I. We're on Google Plus as well. Just look for us there. And we're happy to hear from you. We want to see what you guys are building. And I hope that you use some of these new features to build some cool applications and share them with us.
Yes.
So thanks for joining us. My name is Michael Manoochehri.
And I'm Felipe Hoffa. Thank you for joining us today.